So today we're going to learn the third technique for solving quadratic equations, and this technique is called completing the square. So what we're going to be doing is we are going to turn our equation into perfect square trinomials that will then be able to be factored. Now, generally when you would use this technique for completing the square or quadratic formula, it's going to be an equation that's not factorable, because we're going to end up with a square root in our answer. Now, some of the problems in the homework, you could solve them by factoring, but we need to follow the directions, and the directions are going to say use completing the square. So when you do your work for these, I think there's, I forget how many problems, I think I cut it down to 12. When you're doing this, or maybe 15, I don't know, I don't remember how many I put. But when you're doing it, do all of the problems with completing the square in the 1.4b homework. So these are the steps, and I know it's a lot of words. However, we're going to go through a lot of examples. Now, what we're needing to do, though, first is understand what this a term is, the ax squared, the b, stuff like that. So when your quadratic equation is in standard form, it's in this form. Let me go ahead and do it in white so it shows up. Ax squared plus bx plus c equals 0. So when I refer to the a in my equation, that's going to be the number that's in front of x squared. When I refer to this b that I'm dividing by 2 and squaring, that's going to be the number that's in front of the x. And then when I refer to the c, that's my constant. So what we're going to first do is we want to leave these two terms on the left side, and then we're going to move the constant to the right side of the equal sign. Then if there was a number in front of x squared that's not a 1, we would have to factor it out. Then in order to get my new c term, I have to take the b term, divide it by 2, and square it. Then once I add that to both sides, the left side becomes a perfect square trinomial that when I factor it will turn into a binomial squared. Now I know these are a lot of words and you're like, what is she saying? Perfect square trinomial, binomial squared. As we go through, you're going to understand what I'm saying. Once we get it into this form, then we're going to use the square root method. So let's try some examples. And we'll go nice and slowly so we don't get overwhelmed here, because it is a lot of steps. So let's try it. All right. So the first one, what I need to do is make sure that the number in front of x squared is a 1, and it is. Then my second step is to move the constant to the right side of the equal sign. So I'm going to add 14 to both sides. X squared minus 4x. Now I'm going to leave a blank space here, because in that blank space is going to be my b term that I divide by 2 and square it. So my b term, remember, is the number that's in front of x. I don't take the x with it, just the number. So I'm going to take that 4, divide it by 2, and then square it. So 4 divided by 2 is 2. Then I square the 2 and I get 4. Now, essentially what I'm doing to keep my equation balanced is I'm really adding that 4 to the left side and the right side. However, what I'm going to do just to help me when I go to factor the trinomial is, instead of having now to look at this and say, okay, I've got a trinomial on the left side, it actually is a perfect square trinomial. So instead of sitting here and saying, what are the factors of 4 that give me -4? As long as you remember what you got when you divided by 2, and you put it in here as this part instead of this, when you go to factor it, and that 2 looks weird. Let me fix that 2. When I go to factor the trinomial, you take the x, you take the sign that's here, and then you take this number, and it's squared. I just factored that perfect square trinomial, which really, should say x squared minus 4x plus 4. Factors of 4 that give me -4 are -2 and -2. And again, it's a binomial squared. This will always produce a binomial squared because what we just created here is a perfect square trinomial. Now, remember, question? Good? All right, so now what we need to do is add the 14 plus 4. I get 18. And now I need to use the square root method to find the value of x. So now I'll square root this side, square root this side, and I get x minus 2 is equal to plus and minus the square root of 18. I now, yes? Okay, I now, yes?
Is the minus 2 just for, like, the minus, is it just for this question, or is it always?
No, it's just for this question. So whatever sign is in front of that b term to begin with, that's what sign's going to go in that binomial. Does that make sense? All right, so now I need to break down the 18. I can factor the 18 into 9 times 2. Now, if you did 3 times 6, you'd have to keep going until you can break it down. So this becomes 3 square root 2. So plus or minus 3 square root of 2. And now I move the 2. And my final answer here is x is equal to 2 plus or minus 3 square root of 2. Now, when you're doing your homework tonight on WebAssign, which is due Friday, you have to enter it separately. So you're going to enter 2 plus 3 square root 2 and 2 minus 3 square root 2. It's going to make you enter them individually. Yes?
Will there be one box where we have to do the comma again? Or
You'll have to read.
Two X's.
I think it's 2 X's, but just read the question. Usually in the question it tells you to either enter it with a comma or it'll give you 2 boxes.
Okay.
So my advice to you is tonight, maybe start looking at the assignment, and then that way if you're struggling tomorrow when we're in Zoom tomorrow, if I get through all 10 examples today, I can troubleshoot and we'll do some more examples and I'll help anybody who's struggling with the WebAssign tomorrow. All right, let's try number 2. So again, first check to see if there's a number in front of x squared. There's not. So now I'm gonna, next step is to move the constant. So I'm gonna add 1 to both sides. And I get x squared plus 6x. I'm gonna leave the blank space. And then 0 plus 1 is 1. I now take that b term, divide it by 2. So my b term is 6. 6 divided by 2 is 3. Square that, and I get 9. Now for me, I'm going to put plus 9 here. But instead of putting plus 9 here, I'm going to put what it was before I squared it. So I'm going to put 3 squared in here, just so it makes factoring that trinomial a little bit easier, because now all I have to do is put x plus 3, the number that's in here before you square it. The sign that goes in the binomial is this sign. It's the positive that was in front of your b term. I need to add the 1 plus 9, and I get 10. I now need to apply the square root method. And I get x plus 3 is equal to plus and minus the square root of 10. I now need to move the 3 to the other side by subtracting it. and I get x is equal to -3 plus and minus the square root of 10. And again, you'll pull it apart when you enter it in WebAssign. If this were something on the test and you were just typing something like this in, you could write it out and just do it on your work. But on WebAssign, it makes you do it separately. Let's try number 3. Same thing. Check to see if there's a number in front of x squared. There's not. So now I'm going to move the constant to the other side. I'm going to add 5. I'm going to leave that blank space. And now I take the b term, divide it by 2, and square it, which gives me 1 squared, which gives me 1. So I add 1 to the right side. If you want to put the 1 in there as a squared, you can, but it's the same thing. And now I factor the trinomial. Again, don't worry about trying to find factors of 1 that give me 2. It's sitting right here looking at you. It's x plus 1 squared. And then 5 plus 1 is 6. Apply the square root method. X plus 1 is equal to plus and minus the square root of 6. If I try to break down 6, it just becomes 2 times 3. I can't break it down, so let me just move the 1 over. So x equals -1 plus or minus the square root of 6. Now, these have been all fine and dandy because that b term's been even, and it's been divided by 2 evenly. But in example 4, we got an odd number in the middle. Are we ready? Be good on example 3? Let's try 4. Let me go back? We good? All right. Still, same process though. Check to see if the number in front of x squared is a 1, and it is. Move the constant, so I'm going to subtract 12. Leave the blank space. And now take the b term, divide it by 2. So 7 over 2. I'm not going to divide this and get 3.5. I'm going to leave it an improper fraction. I'm going to square it though, so I know what to add to the -12. 7 squared is 49, 2 squared is 4. Now again, this is where it pays off. Here, the 7 over 2 squared. Over here, I got to put the 49 over 4 because I'm going to have to add these two numbers. Now, when you go to factor the trinomial, again, you know, don't be afraid that there's a fraction there. Remember, all you do is take it, and it's x plus 7 over 2 squared. We're not trying to turn it into 3.5 and try to find the factors of 3.5 that give me 7. Okay, over here though, I do have to combine -12 plus 49 over 4. So let me put it up here. So -12 over 1 plus 49 over 4. I need to find a common denominator. It's going to be a 4. So I can see here I have to times top and bottom by a 4. So this new fraction becomes -48 over 4. Once I add them, I get 1/4. So that's what's going to go right here. Now I apply the square root method. Square root the left side and the right. This gives me x plus 7/2 equals, and I can root the fraction individually. Square root of 1 is 1, square root of 4 is 2. So this gives me plus and minus 1/2. Now, on this particular problem, we're going to have to actually do it because there's no radical. So let me go ahead and, just so I don't cram it all in, I'm going to move the problem over to here. So now I have x plus 7 over 2 equals plus and minus 1/2. I'm going to move the 7/2, and I get x equals negative 7 over 2 plus or minus 1 over 2, or 1/2. I have to do them and figure out the fraction, or in this case, they're going to be integers. So I'm going to first do negative 7 over 2 plus 1/2, and then I'm going to do negative 7 over 2 minus 1/2. I actually have to do this plus minus thing. So here, negative 7 plus 1 is negative 6 over 2, which gives me negative 3. Then if I do negative 7 minus 1 is negative 8 over 2, which gives me negative 4. So my two solutions for this problem are negative 3 and negative 4. Good? All right, let's try the next one. We need to, again, check to see if there's a number in front of x squared. There's not. It's a 1. I'm going to move the constant, then divide the b term by 2 and square it. So let me move the constant first. Add 6. X squared minus 3x, leave the blank space, equals 6. Ashley, you have a question?
Yeah. I mean, how do you know when you're supposed to use this method over the other methods that we learned the other day?
Okay, so if you were taking this on an SAT, PSAT, or something else, and it doesn't specify and it just says solve the quadratic, you can use any method you want. Now, the difference though between what we learned yesterday and what we're learning now is if you're given a quadratic equation that cannot be factored or cannot be solved using the square root method, then you only have two options for non-factorable equations. It's either this or quadratic formula.
Okay.
Now, my advice to you is, and I know you guys don't like to factor, but honestly, if the equation can be factored, that's the fastest way, okay? However, I like I said before, I'm 99% sure that you will have to demonstrate this method on the test. All right, everybody good? Every year we do. Once we're going to do this again later on when we get to graphing the quadratics, and we've given like a 2-question quiz where you have to do all of the steps using completing the square. So we will be doing completing the square multiple times throughout the school year. Now, one other thing that when we complete the square and these two values of x that we just found, these are actually our x-intercepts. So not only are they called solutions, they're also called x-intercepts, they're also called zeros. So if you happen to see this on a PSAT or an SAT, and if they say find the zeros of the quadratic, this is what they are. It's the x values. If it says find intercepts, they would expect you to solve this and then turn them into ordered pairs. So it would be whatever number you get, comma 0. Everybody good? All right, let's do number 5. So here, again, I've already moved the constant. I need to take that b term, divide it by 2. So 3 divided by 2, and then I'm going to square it. Again, don't make it 1.5, leave it improper. This gives you 9 over 4. So in here,
you're not sign of the number?
you can put the sign of the number if you want, but just remember when you square it, this becomes positive. Now, if you'd prefer to leave the sign in there, you can, but just remember when you go to factor the trinomial, you're using the sign that was in front of that 3x. Does that make sense?
Yeah, I just thought that if it was positive on one side of the equal sign, wouldn't it be negative on the other?
No,
Like
because,
if I did -3/2 squared on the left, then wouldn't I have to do 6 minus 9/4?
no, because, all right, that's a different technique where if you don't have an equal sign, you just leave a space, and then it would be opposite sign. So it depends on how you're learning this, but because I've moved it to the other side, and I'm using my properties of equality, where I need to keep the equation balanced, so whatever I add to the left side, I'm adding the exact same thing to the right side. So I'm actually adding 9/4 to both sides. Does that make sense? Good? Ashley, you have another question, or are you good?
This is the end of the first lunch. Please proceed to EF period. Thank you.
Okay, so I've already factored the trinomial, but now I have to add 6 plus 9/4. I need to find a common denominator, and it's going to be a 4. So what I'm doing is timesing top and bottom here by 4. So this will become 24/4. And when I add 24 plus 9, I get 33/4. So that's what goes here. And now I use the square root method. And I end up with x minus 3/2 equals plus or minus 33 can't be broken down, but I can do the square root of 4 and it becomes a 2. I now need to move the 3/2 to the other side. So then now I end up with x equals 3/2 plus or minus square root 33/2. Now, keep in mind on SET, PSET, you might see it with only one denominator. So you could also, but WebAssign's going to expect you to leave it separated. You can also do this and just write the denominator of 2 one time. So you could actually put both numerators together with only 1 2 in the bottom. Let's try number 6. All right, here's where it changes up. Now we actually have a number in front of x squared. So what I need to do is get rid of that 9. So either think of it as factoring it out. What I'm going to do is divide everything by 9. So divide this by 9, 9, 9, 9. Now I'm left with x squared. I'm going to reduce 12/9 to 4/3. And now I move the constant. Now the steps are the same. Move the constant, take the b term, divide it by 2, and so on. So let me move the constant. X squared minus 4/3 x, blank space, 1/9. Now, remember, we're dividing the b term by 2. So, for example, I'm doing 4/3 divided by 2. So whenever it's a fraction, I don't think of divide by 2, I think of multiply by 1/2. Because remember, you do a keep flip change here. So really it's 4/3 times 1/2. I can simplify diagonally, and this gives me 2/3. I now need to square it, and what I'm adding to that right side is 4/9. So now over here, plus 4/9, but in here I'm going to put the 2/3 squared. I'll factor the trinomial. It factors into x minus 2/3 squared. Add the right side, it's already got a common denominator, so I just do 1 plus 4, and I get 5/9. I now apply the square root method. So I square root and square root, and then I'm left with x minus 2/3.
You are in EF period. Thank you.
Okay, so I've square rooted. The 5 can't be broken down, but the square root of 9 is 3. I move the 2/3 over. So, yes,
Wouldn't the 3 also be plus or minus?
the 3. The denominator, you mean?
Yeah.
Yeah, so just think of this plus minus as being in front of that whole fraction. So plus or minus square root of 5 over 3. Good? You just need to put the plus minus in front of one of them, either in front of the whole thing or top or bottom. You wouldn't put it on both because then it would become positive. Everybody good there? All right, let's try the next one. Good? Yes, no?
Oh,
You're good?
yeah.
Okay. All right. Next one. Again, same thing. I'm going to divide everything by 3 before I start my process. And then I'm left with x squared plus 2/3 x minus 5/3 equals 0. Move the constant. X squared plus 2/3 x, leave the blank space, equals 5/3. I now need to take the b term. And again, remember, since it's a fraction, you don't really need to think of it as divide by 2, just think of it as times by 1/2. So my b term, I'm going to take 2/3, times it by 1/2, simplify, I get 1/3. So it's 1/3 squared. So I'm adding 1/9 to this side, but in here I'll put the 1/3 squared. Factor the trinomial, becomes x plus 1/3 squared. I need to find a common denominator between my 3 and 9 here. So it's going to be a 9. So I'm timesing this by a 3 and this by a 3. So I get 15 over 9. So 15 plus 1 is 16. Apply the square root method. And now I have x plus 1/3 is equal to plus and minus 4 over 3. Move the 1/3. And x is equal to negative 1/3 plus or minus 4/3. I got to do the math on this because there's no radical. So I actually have to do x equals negative 1/3 plus 4/3. And then also x equals negative 1/3 minus 4/3. This gives me 3 over 3, which is 1 whole. And then here gives me negative 5 over 3. So my two solutions are 1 and negative 5/3. Three more examples. Same stuff, nothing new. We're going to divide, make sure that the number in front of x squared is 1. Maybe tomorrow we'll do some with fractions in front of the x squared. Those will be a bit more challenging. Let's try number 8. So again, same thing. Get rid of the 3 first. So divide everything by 3. And then we get x squared minus 4/3 x minus 1/3 equals 0. Move the constant. X squared minus 4/3 x, leave a blank space, equals 1/3. Take that 1/3, or I'm sorry, the 4/3, and we're going to divide it by 2, which is times by a half, and then square it. So 4/3 times 1/2, simplify, gives me 2/3, square it, and I get 4/9. So I'm adding 4/9, but I'm adding 2/3 squared here, which is really 4/9. Factor the trinomial, sign that was in front of that b term, and then the 2/3 squared. I need to find a common denominator here, so it's going to be a 9 times by 3 times by 3. This gives me 7/9. Apply the square root method, and x minus 2/3 equals plus and minus square root 7 over 3. Add the 2/3, and x equals 2/3 plus or minus square root 7 over 3. And you're done. Number 9, same thing. For number 9, I'm going to divide everything by 5. And I get x squared minus 7/5 x minus 1/5 equals 0. Add the constant. X squared minus 7 over 5x, leave the blank space, equals 1/5. Take that b term, the negative 7 over, or the 7 over 5, again, divide it by 2, which is really multiply by a half, and I get 7/10. Square it, 49 over 100. So that's what I'm adding in here, 49 over 100, but here I'm going to put the 7/10 squared. Factor the trinomial, x minus 7/10 squared. Common denominator between 1/5 and 49 over 100 will be 100. So change this 1/5 to 20 over 100. That's 600, 100. So then I'm going to add 20 plus 49, and I get 69 over 100. Use the square root method. X minus 7/10 equals plus or minus. I can't find the square root of 69. It is already simplified. So I leave square root of 69 underneath, but I can square root the 100 and I get 10. Move the 7/10. Now all of the examples I have done, they've all had the same denominator, but that doesn't always happen. So 7/10 plus or minus square root 69 over 10. One last example. Again, my term or my a value has to be a 1. So I'm dividing everything by -1 to get to have a positive 1 in front of x squared. So this gives me x squared minus 3x minus 5 equals 0. Move the constant. X squared minus 3x equals 5. Again, take the b term, divide it by 2. So 3 divided by 2 squared gives me 9/4. It's what I'm adding to both sides. 9 over 4. Again, I'm going to put it in here as the 3 over 2 squared. This trinomial factors into x minus 3 over 2. I need to do the math for this. So 5 over 1 plus 9 over 4, common denominator 4. So it becomes 20 over 4 plus 9 over 4, which gives me 29 over 4. And that's what goes here. Do the square root method. X minus 3/2 equals plus and minus square root 29 over 2. Move the 3/2. And x equals 3 over 2 plus or minus square root 29 over 2. And we're done.